Okay guys, in this chapter we're going to look at areas of circles and sectors. And so I've drawn 3 circles here and I've split them, I've cut them up a little bit. Now as I've been saying, in geometry, if you want to find the area of something you don't know, then you need to make that shape into something that you do know. Now the problem, unfortunately for most of you guys, is that you already know the area of a circle, so I can't make you unknow that, but I can at least show you where it comes from. And so if we look at this picture here, basically, so let me give you the formula. Most of you guys know this, I'm sure. The formula is area equals pi r squared. Now, whenever you see a formula, okay, whenever you see a formula, this is obviously an algebraic formula. You try to understand what does that look like visually. Okay, how can I geometrically represent that? Okay, well, r squared, what that looks like, that's basically a box right here. So that would be r times r, that's a square, right? And then if you take the area of that box and multiply it by pi, then that's going to be the area of the circle. And so that doesn't necessarily help, I don't think, you know, r times this box times pi. That doesn't really help me see where this comes from. But if you look at this and you think about it like this, area equals, let's say, pi r times r. If you split it up like that, then this is going to be a rectangle with length pi r and width r. And that's what we're going to try to do here. So let's go ahead and I want to just split this up. Okay, so there's 4 little wedges here. And so what I want to do is rearrange those wedges. Okay, so I've just rearranged the radii of those wedges. All right. And so what we have here then is just a rearrangement of this circle, and it's not exactly to scale, you know, but this would be if I could rearrange these wedges, then I could do that. Okay, and I want to notice here, I want to do the same thing here. Okay, let's say we do this. Okay. All right, so I have eight little wedges here. So 1, 2, 3, 4. 1, 2, 3, 4. And in a perfect world, I would be drawing these, you know, exactly, you know, this yellow distance should be the same here and here, and all of these these blue lines should be the radii, so those should all be the same. And what you see here is a pattern starting to happen, or a pattern starting to develop. I hope you see that. So let me draw this last one. This is going to be a bit tougher. We've got a lot of wedges here. 3, 4, 5, 6, 9, 10. Okay, so that should give me 16 wedges. Let me check. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so at first we see that this shape kind of looks like a shape we don't really recognize. But as we get further and further, you can see that this shape is starting to look a lot like a shape that we're very familiar with, and that would be a rectangle. Okay, particularly this looks like a rectangle. We know that this blue line in all of these, that just represents r. Okay, so this is r. This is r, this is r, okay? So this line is r, and then the top, it looks like that's going to be, in this case, 1, 2. So 1, 2 is going to be, again, 1, 2, 3, 4. 1, 2, 3, 4. That's going to be half of the circumference. Half of the circumference. Well, the circumference, we know, let me write it over here. The circumference is equal to 2 pi r. Okay, so half of that is just pi r. So this distance, you know, if we could take the arc length, right, then that would be pi r. Same here, this would be pi r. And the same thing here. This distance, again, the arc length would be pi r. Pi r. And so now you can see, of course, we've only taken 4 segments, 8 segments, 16 segments. But if you were to take 32, 64, 100, a million, a billion, a trillion, okay? If you took a trillion equally sized wedges of this circle and lined them up in this fashion, you would get something, I'm sure you could not even differentiate it from a rectangle with width r and length pi r. So this idea, okay, this idea of taking more and more pieces of smaller and smaller objects, okay? So infinite amount of pieces of infinitesimally small objects, okay? That idea is the very, very foundation of calculus. And so if you can understand this, then I promise you can understand calculus. There's nothing in calculus that you can't understand if you understand this concept, because this is the very foundation of calculus. So even though this is a geometry, you know, you'll use this idea a lot in calculus. And this idea, by the way, is called the idea of a limit. So one of the very, very important ideas in mathematics. But anyway, so area of a circle is pi r squared. Many of you probably knew that before watching this video. So I hope this sort of explains where it comes from. Now, we have another thing I want to talk about. Let's say I want to take the area of this wedge. In mathematics, we call this a sector. So the area of a sector. Okay? So area of a sector, maybe this is not as commonly known, but I want to give you 3 examples. Okay? Let's say we have a circle, okay? And let's say we have a semicircle, and let's say we have a quarter of a circle, okay? And we can even take a quarter of a circle, okay? So the area here, well, we just talked about is going to be pi r squared. The area here is going to be half of pi r squared. And we know that because this is 180 degrees. Of course, a circle has 360 degrees, right? So, okay. This is going to be 90 degrees. So in other words, 90 out of 360 is 1/4. So 1/4 pi r squared. Okay, if this is 45 degrees, if that's 45 degrees, then this is going to equal 1/8 pi r squared, etc. So I think you can get the idea. So whenever we have a sector, okay, whenever we have a sector, we're always looking at this number, this number, this number. Where did those numbers come from? Well, that came from, let me write this over here in yellow, that came from 180 over 360. 1/4 came from 90 over 360. 1/8 came from 45 over 360. And this 1 here came from 360 over 360. Okay? So whatever the percentage of the circle that you're looking at, you just multiply that percentage by the area of the whole circle. So if this is n degrees, instead of doing 360, 180, 90, or 45, you just do whatever portion of the circle that is. So find the area of the whole circle. So this is going to be r. So find the area of the whole circle. So the area of a sector, I'm going to write right here. So the area equals, you're going to find the area of the whole circle, so pi r squared. Okay? And then you're going to multiply that by the percentage or the portion of the circle that you're looking at. Okay? So that would just be n over 360. So n over 360 times pi r squared is how we're going to find the area of a sector. Okay, in the next video, we're going to look at some examples and hopefully try to utilize what we've learned here. Thanks for watching.